In this video, we're going to review how to graph quadratics. But before we actually get to the graphing, let's talk about the three different ways we can write a quadratic equation. The first is in standard form, which is y equals ax squared plus bx plus b. Basically, in this form, we're just substituting a number for the coefficients of a, b, and c. An example would be y equals 3x squared minus 6x minus 1, where a is the 3, b is the negative 6, and c is the negative 1. From standard form, there's not a whole lot we know about the graph without doing a little bit more work. But one thing that we do know, we know it's going to be a parabola shape. All quadratics are parabola shapes. And this one is going to be open up because a is positive. And the c in standard form is going to always be your y-intercept. Other than that, there's not a whole lot we can glean from standard form without putting in a little bit more work. We'll go into more detail about standard form a little later. Vertex form is the form y equals a times x minus h squared plus k, where hk is the vertex. So in this example that's written, y equals 1/4 times x plus 2 squared minus 3, our vertex would be -2, -3. -2 is your h. It's going to be negative because of this minus h. So minus a -2 would make that a +2. So our h is -2 and our k is -3. So if our vertex is -2, -3, we're already off to a great start if we were going to be graphing this quadratic in vertex form. The vertex is the most important part of the graph. And we also know if this is our vertex, then our axis of symmetry is at x equals -2, because the vertex is always on the axis of symmetry. And so these two numbers always match. But we'll go into more detail with that later also. The last form is intercept form, or a lot of places call it factored form, where we're given the factors for the quadratic. In this case, -3, x minus 2, and x plus 4 are all factors. If we set each one of those factors equal to 0, it tells us what the x-intercepts of the quadratic are. So in this case, we know one x-intercept is +2 and the other x-intercept is -4. And already we have 2 points on our quadratic graph. In this one, also, because the a is negative, this parabola is going to be an upside down one. So let's talk about the characteristics of a quadratic function, and then we'll get into the graphing of a quadratic function. So first, quadratic functions always have a domain that is all real numbers. Any number can be plugged in for x. The range, though, is limited based off of where your vertex is. So let's actually talk about the vertex first. The vertex in this case is the point -3, 7. The vertex is either the maximum point of the graph or the minimum point in the graph. In this case, the vertex is the maximum because it is the highest point on the graph. So our vertex is a maximum. And we would say the maximum value, or the uppermost value, is 7. And the maximum value occurs when x equals -3. X equals -3 is our axis of symmetry. I'll call it A of S for short. Axis of symmetry is x equals -3. And then with this information, now we can go back and figure out our range. Because our maximum value is at 7, that means all of the y values are below 7. or equal to 7. So our range, because our range talks about the possible y values, our range would be y can be any number less than or equal to 7. Or another way of writing that would be y can be any number from negative infinity to 7. And we do want to include the 7. So that's what it would say in interval notation. Other characteristics about this graph, if we wanted to say where the function is increasing and where the function is decreasing, increasing means where does the quadratic, what parts of the parabola is the quadratic have a positive slope, and at what parts during the graph does it have a negative slope would be decreasing. So on the left side of the graph, it is increasing. It's going up, 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 up. So, and on the right side of the graph, it's decreasing. It's going down, 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 down. Oops. Let's get rid of that. And so if it's increasing to the left of right in the middle where it switches from increasing to decreasing is -3. So if it's increasing to the left of -3, we would say it's increasing when x is less than -3, and it's decreasing to the right of -3 or when x is greater than -3. So those are all the characteristics of a quadratic function. Let's talk about graphing one now. We're going to start by graphing 2 in standard form, then we'll do 2 in vertex form, and we'll end with 2 in intercept form. So standard form first. To graph in standard form, the only thing we know about this quadratic graph really is that the a is -2. And since the a is negative, that means that our parabola is going to be upside down. It's going to open down. Our vertex is going to be a maximum. To find the vertex, first we need to find the axis of symmetry. And our formula for finding the axis of symmetry when it's in standard form is x equals -b over 2a. In this case, b is 8 and a is -2. So what we get for our axis of symmetry is -8 over -4, or x equals 2. That's a vertical line. So this is our axis of symmetry, arguably the most important part of our graph. To figure out the rest, I'm going to make a quick XY chart for my function. And the first point I'm going to plug in into my XY chart is the axis of symmetry 2, because this is going to tell us where our vertex is, since our vertex is always on the axis of symmetry. So when I plug a 2 in, I'm going to get -8 plus 16 minus 3, or 5. So the point 25 is the vertex. Now I'm going to plug at least 2 more points into my XY chart. I always like to plug in 0. 0, we know we're going to get 0 plus 0 minus 3. So our y-intercept is -3. And then we can also reflect that point over our axis of symmetry to get a point at 4, -3 as well. And then I need to plug in one more point. I'm going to plug in a 1. When I plug in a 1, I get -2 plus 8 minus 3, which would be 3. So 1, 3. And I can reflect the point 1, 3 over my axis of symmetry to also get the point 3, 3. So here is my parabola. Let's do another one in standard form. So again, in standard form, we always want to start by finding our axis of symmetry. I'm going to label my A, my B, and my C. Because A is positive, this is going to take on the shape of a parabola that opens up. And the axis of symmetry is x equals -b over 2a, or in this case, +6 over 2 times 1, which is 3. So when I go to make my XY chart, the first number I'm going to plug into my XY chart is 3, because if I plug in the axis of symmetry, that point is going to be my vertex, which in this case is going to be the minimum point on our graph. So when we plug in a 3, I'm getting 9 minus 18 plus 4, or negative 5. So our vertex is at 3, negative 5, and that's our minimum point. I love plugging in 0, so we get 0 minus 0 plus 4. So our y-intercept is at 4. And if I reflect that point, I get a point at 6, 4 also. And then I'm going to plug in 1. When I plug in 1, I get a negative 1. And when I reflect that, I get 5, negative 1. For parabolas, we really need at least 5 points, 5 good points on our graph to get a parabola shape. If you only do 3, then you're not getting the curve correct, and it could look like an absolute value graph. So make sure all parabolas have 5 points on them. All right, so now let's talk about how to graph in vertex form. So remember, vertex form, just by looking at it, we know what the vertex is. This plus 2 tells us that our graph is moving to the left 2, and this plus 5 tells us that it's moving up 5 from the parent function, which is normally at 0, 0. So our vertex is to the left 2 and up 5 from 0, 0, or negative 2, 5. And if our vertex is at negative 2, 5, that means our axis of symmetry is at x equals negative 2. So just by looking at vertex form, we already know the most important pieces of our graph. We know the vertex and we know the axis of symmetry. Also, just like before, this front number, just like standard form, the front number is your a. So because my a is negative 1, I know that this parabola is going to open down. Now, even though that front number is still a, that does not mean the 2 is your b and the 5 is your c. Remember, this is vertex form, not standard form. The only coefficient that really matches up here is a. All right, so we have the vertex, we have the axis of symmetry. We need at least 5 points to make a good parabola. So I'm going to make my XY chart here, and I'm going to plug in 2 more points. So I'm going to plug in 0. 0 is not as easy to plug in with vertex form because we do have to follow order of operations. So parentheses first, then exponents, so 2 squared is 4. Then we can multiply by that negative to get negative 4, plus 5 is 1. So I've got a point at 0, 1, and when I reflect that point, I also get a point at negative 4, 1. And I like to plug in points that are pretty close to the axis of symmetry, so I'm also going to plug in negative 1. When I plug in negative 1, I do the parenthesis first to get 1. 1 squared is 1. Then we're going to make it negative. Plus 5 is 4. So negative 1, 4. And I can reflect that to get the point negative 3, 4 as well to finish up my 5 points for my quadratic. Let's do another example in vertex form. So this time our a is 1/2. That's your a. But remember, the other numbers are not your b and c. That's your vertex. So our vertex is positive 3, negative 4. It's moving right 3 down 4. The vertex, I should say, is moving right 3 down 4 from the parent function. So my vertex is at positive 3, negative 4. And if that's where my vertex is, then that means my axis of symmetry is at x equals 3. So already I have the most important pieces of my graph. I know because my a is positive that this graph is going to open up. So that vertex is a minimum. And then I'm going to make an XY chart to get a couple more points on our graph. I can work a little harder to come up with points to plug in to get nice, pretty answers for y, but it's okay if we end up getting a fraction. So, for example, I could plug in a 1. And when I plug in a 1, I get -2 squared, which is 4. So I'm taking 1/2 of 4 minus 4. Well, that comes out pretty nicely because 1/2 of 4 is just 2. 2 minus 4 is -2. So 1, -2 is a point on our graph. And when I reflect that, I also get a point at 5, -2. But if I plug in a 2, which is pretty close to our axis of symmetry, I'm not going to get a nice, pretty answer. So I'm going to get 2 minus 3, which is -1. Squared is 1. So I have to take 1/2 of 1 minus 4, or 1/2 minus 4, which is -3.5. And it's okay that my answer wasn't nice and pretty. You can try plugging in a different point to get a prettier answer if you want, or you can just work with what you have. But I've got 5 points on my parabola now. That's enough to call it a quadratic. Next, we're going to review how to graph a quadratic that's an intercept form or factored form. So these are the factors. The front number, the front coefficient, is your a again. So our a is -1. There's an invisible 1 there. Which means that this parabola is going to open down because a is negative. But that 1 and that -5, those are not your b and c. Instead, we call them p and q. They help us find our intercepts. Or I should say the factors help us find our intercepts, p and q. So to find our intercepts, we're going to set each one of those factors equal to 0. And we get that one intercept is at -1 and one x-intercept is at +5. So if I graph those, -1 and +5, I have 2 points on my parabola already. From here, we're going to find our axis of symmetry, because I think the axis of symmetry is a really important part of our graph. It's what we reflect everything over. And so because we know the axis of symmetry cuts our graph in half, and these points are going to be mirrors of each other, then our axis of symmetry needs to be right in between the 2 points that we have, our 2 x-intercepts. So we have to ask ourselves, what number is right in between -1 and 5? And in this case, it's pretty easy to figure that out. It's going to be at 2. But if you ever have trouble figuring it out, to find what's right in the middle of 2 numbers, we take the average. So we would add the 2 numbers together and then divide by 2. So because our axis of symmetry is at 2, 2 is going to be the first number I plug into the XY chart, because that's going to give me the vertex. And in this case, we know that the vertex is going to be a maximum. All right, so when I plug in a 2 into our XY chart, I get negative times 2 plus 1 times 2 minus 5. Or -3 times -3, which is 9. There's our vertex. I have 3 points on my graph. I just need 2 more. So now I'm going to plug in any point. Because my axis of symmetry was 2, I'm going to plug in 1. So -1 plus 1 times 1 minus 5, or -2 times -4, which is 8. So I have the 0.18 on my graph, which means when I reflect that, I also have the 0.38 on my graph. That's 5 points and enough to graph our parabola. One more graph. This one is also an intercept form. This time my a is 2. Because a is positive, this is going to be a parabola that opens up. And this is intercept form or factored form because it gives us factors that can give us our intercepts, our x-intercepts. So we're going to set them equal to 0. to find out that our x-intercepts are -3 and +1. Remember, it's helpful to know where your intercepts are because if we know where our intercepts are, we can figure out our axis of symmetry. Our axis of symmetry will be right in between our two intercepts. So in this case, -1. And again, if you have trouble figuring out what's right in between the two numbers, take the average of them. In this case, -3 plus 1, and then we divide that by 2. So when I make my XY chart to find some more points on our graph, the first number I'm going to plug into the XY chart is going to be -1. Actually, let me use red. There we go. Because that's our axis of symmetry. If I plug in -1, I'm going to know what my vertex is. So when I plug in -1, I get 2 times 2 times -2, which is -8. So -1, -8 is my vertex. I need 2 more points. Right now I have 3. Since -1 was my axis of symmetry, I'm going to plug in a 0. And when I plug in 0, I get 2 times 3 times -1, or 0, -6. And when I reflect that, I also get the point -2, -6. That's 5 points, enough to draw a parabola, and we are done.